Hello and welcome to our new Appium series. Appium is a great testing framework. With our first tutorial, we want to help you to set up Appium on an OS X machine and test an Android device. During this tutorial, we will download some files from different websites. Here you see a list of these websites, which you can also find in the description below. First up is Appium, which you can download right from the cover page of the official website appium.io. After you've downloaded and installed Appium, we can move on to the Appium Java client, which we can grab from the official GitHub page. You can find the download button on the lower part of the right sidebar. Next up is the Selenium standalone server, which can be downloaded from the Selenium website. Save the jar file in any place you like. We will need to import them later in our IDE. In this tutorial we will be using IntelliJ IDEA, but feel free to use your editor of choice. If you have never used an IDE before, sticking to IDEA for this tutorial will probably be easier for you. The free community edition has everything we need. Since we will be testing on Android, we will need to provide Appium a working Android SDK. We can get this on the official Android developer website in the Other Download Options section. If you already have Android Studio installed, you already have the SDK on your machine, and you will just need to locate it. If you don't, however, you will need to download the OS X version from the website. We will be testing on a physical Android device, which must be connected and recognized by our machine. Make sure this device also has USB debugging enabled. If you are not sure about how to set up an Android device for USB debugging, you can check the short guide on the Android developer website. The last step we must take before we can run Appium is fetching the Android build tools. To do so, we navigate to the folder where we have unpacked our SDK. And we then enter the Tools folder. Here we right-click a random element and select Get Info from the drop-down menu. This will allow us to select and copy the path of the folder we are in. Then we open a terminal window. You can do this by pressing Command Space, typing in terminal and pressing Enter. Here we type CD, followed by a space and the path we just copied. By hitting Enter, we navigate to the Tools folder via Terminal. Once we are here, we must start the SDK Manager. Type in /Android and hit Enter once more. You should see the SDK Manager pop up any moment. We need the SDK Manager to download the Android build tools. Since we won't be writing Android apps, we won't need most of the stuff that is already selected for download here. Go ahead and deselect the extra libraries by clicking on the active checkboxes. When you are ready, click the Install button. You will need to accept the SDK license. Now that we have all our tools in place, we need to configure Appium. Click the Android icon to open the Android settings menu. Don't feel intimidated by the number of options that have just appeared in front of you. You won't need to fill them all out. Firstly, we need to provide the location of the APK file containing our app. To do so, we must click the checkbox next to the app path label and click the Choose button. This will allow us to navigate to our APK file and manually select it. Now we need to provide Appium with a device name. You can name your Android device however you choose, but you must provide a name. If you skip this step, Appium will not work. Again, select the checkbox and type in the name. For the last setting we must provide, we navigate to the Advanced tab. Here we select the checkbox next to Android SDK path and we provide the path to the SDK. This is the path we copied before from within our SDK folder, minus the tools part. Click on the Android icon to close the settings window. We are finally ready to run Appium and see if everything works as it's supposed to. Let's now press the launch button and start the Appium server. You should see the first messages appearing in the log. Now we can click the lens icon and start the Appium Inspector. Your app is getting installed on your phone right now. Be patient as this process can take some time. You can now see the inspector booting up on our main machine and the app opening up on our Android device. The Appium Inspector is a fundamental tool that allows us to reference UI elements in our application. On the right frame we can see the initial screen of the Komoot application, which we will control in a minute. In this moment we have the same screen on our Android device and on the inspector, but we will soon see that the inspector just takes snapshots. What we see is not a live feed from the device. The frames on the left allow us to navigate the UI from the root element to the innermost ones. The easiest way to move around the UI elements is to use the arrows on your keyboard. As we select specific elements on the screen, they become highlighted by a red border on the right frame. This helps us keep track of where we are. When we select an element, we see the values of its attributes appear in the central frame. It is by using these values that we will be able to reference the UI elements in our application and interact with them. For the purpose of our test, we will be clicking the Log in with Email button on the bottom of the screen. To do so, we will use this element's ID, which we can find under the label Resource ID. Just copy this and put it on the side for now. We will be using it shortly. Now it is time to open up our IDE and import a couple of dependencies before we write our test. Now we create a Java project. The first steps are pretty straightforward. Click Next until you are prompted for a title. Here you can insert the title you prefer and the location where your project will be saved. When you're done, press Finish. Once your project has been initialized, navigate to File, Project Structure. Here select the Libraries tab. Now click the plus button on the top of the window to import new libraries. Select Java, as we will be importing Java dependencies. Now you just have to select the two jar files we downloaded, the Appium Java client and the Selenium standalone server. Once you're done, click the OK button. Having all the setup taken care of, we can now create the first class in our project. To do so, we navigate to the source folder of our project and right-click on it. From here we navigate to New Java class, insert a name and click OK. The first thing we have to do is to take care of the setup of our test. Using the annotation add before, we specify what will be done before the test is executed. Our setup method will take care of setting up the connection with the Appium server while providing the needed capabilities. Even though we have provided the device name through the Appium interface, we still need to specify it here as well. Next up, we establish a connection with the Appium server. This is accomplished by using the Appium driver class. We provide our driver with a URL pointing to our machine. This address is the same for every computer. Ending with the port the Appium server is using, the default one being 4723, and /wd/hub, and the capabilities we have just defined. As you can see, we are confronted with the need to handle an exception. In this case, though, the exception will never be raised, as we are always providing the same URL that we know can't be malformed. So we simply add a throw clause in our method signature. The driver is the key piece of our program, and we will need to reference it outside the setup method. For this reason, we will be declaring it as a global variable. Since we now have the setup phase covered, let's move on to the shutdown part. Similarly to the setup method, we will be using an annotation to make sure this new method only runs when the test is over. In this case, we won't need to catch any exceptions that are raised either, as an error happening now would be reported through Appium, and for our test we don't need a more complex behavior. The body of our method contains a single instruction, the one that closes the connection with the server, effectively freeing up the session for reuse. We are finally ready to write our first test, which will also be introduced by an annotation. Since we will be clicking the Login with Email button, we will be naming our method Click Login with Email button. Always try to give significant names when writing tests, as this will help you keep your code clean and readable. This becomes really important when you start working with a big number of tests. To click our login button, we first need to reference it in our program. We do this by instantiating an object of the web-element class and asking the driver to provide us with the correct element. We specify the correct element using the ID we grabbed a few minutes ago using the inspector. So now that we have our button, we can click it by invoking the click method. Before running our test, we will need to close the inspector and restart the server. As of version 1.4, closing the inspector is not enough to free the session for the tests. That's why a restart is needed. Once the first logs have appeared, we can run our test. To do so, switch back to Idea and navigate to Run. Run, select the test you would like to run, and press Enter. You should notice a number of things. First, the IDE launches the test you have selected. Second, the Appium server is installing and running your application. You can tell that this is the case by looking at the messages coming up in the log. Third, you should see the application being launched on your device. In our case, it was already open and now it's been launched again. And the actions you have specified in your test being replicated on the screen. In this case, what we did was a simple tap on button, so there really isn't much to see. And while the green bar in our IDE tells us that our test was successful, what we ran was not really a test in the deepest sense of the word, since we did not check an expected result against an actual result. But we can fix that in just a couple of minutes. We will be implementing the rest of the use case, so again trying to log in with an invalid email. For this, we will need to reference other UI elements, so we have to fire up the inspector once again. Since we will need to interact with elements from another screen, we must have them show up on the inspector. To make this happen, we navigate to the screen we need on our physical device, and then click on the refresh button in the inspector. Now we are ready to interact with UI elements on the screen. As we did before for the login with email button, we can now navigate to the email and password fields. We will need to input some text here, so we grab the IDs. Let's now go back to our IDE and see some more interesting instructions we can make use of. First of all, we must take into consideration the fact that this second screen might take some time to load, instead of showing up immediately. For this purpose, we must wait some time before grabbing our referenced field. We could tell our program to stay idle for a fixed number of seconds, but we can do better. We can actually tell our program to wait until an element shows up, while providing a timeout so it won't hang forever if the element is not shown. What we have just written may look complicated, but if you stop for a moment and read the instructions, you will find it pretty self-explanatory. First, we specify we want to wait for a maximum of 60 seconds. Then we write we want to wait until some condition is verified. In this case, we are waiting for an element to show up on the screen, and we specify which element we are waiting for by providing its ID, which is the one we just copied from the inspector. Now that we have referenced the element, we can interact with it. In this case, we want to write some text into a text field, or specifically into an edit text. For this purpose, we use the sendKeys method, which will essentially paste a string into the field. To keep the code tidy here, we use a constant to store our invalid email string. This is a good way to keep your code tidy and make it easier to modify the code in the future. We must also reference the password field and input a password. So again, we grab the element and enter a string. Now that we've filled both fields of the form, we need to click on the button to log in. We use the procedure we are now familiar with to grab the ID and click. What we need to do now is to replicate this sequence of actions on our device so we can check what outcome they produce. So turn your attention towards your connected device for a second. What happens when we press login will be our expected result, the one we must check every result against. This message will be the desired outcome of this use case, so we will need to reference it and verify it is showing. We already know how to do this. We navigate to the inspector and press refresh. Then we select an element of the message. This time we will not act on it, but use it to check that the expected message is there. Remember, the message will not be available immediately, so we must use the technique we learned earlier. Finally, we use an assert equals clause to check that the error message on the screen is the one we should be getting. To be sure your expected message is free of typos, copy it from the text attribute field in the inspector. Make sure to add this last import for the assert. Now everything is set. We can launch our first true test using Appium. Remember, always close the inspector and restart the server before launching your tests. You can see all the actions we specified being executed one after another. And here we have the results we were expecting. You can also see that our test has succeeded from the green bar in the IDE. Congratulations on your first test. It was our pleasure to guide you through it. If you want to run your Appium tests on a number of devices, visit us at testobject.com.